Okay, I'm going to go ahead and get started. Hey. So, just as a reminder, because this week is a little different, remember that the homework and the quiz, well, no, remember that the quiz is due on Monday. The only reason it was due Wednesday last week is because Monday was a holiday. So as a reminder, it's due on Monday. Now, some of you have already noticed, some haven't. The homework has been changed. And I did make an announcement about it, so if you need to check it, but basically homework number 2 became homework number 3. The reason homework number 2 became homework number 3 is because it dealt with conversions. And on Wednesday, I decided to go back over calculations with significant digits, therefore delaying when I started conversions. So since I delayed when I started conversions, I'm delaying when that homework is due. So it became homework number 3. What it means is everybody's going to get a free 10 for homework number 2. Now it will only show up on Blackboard, and it'll be next week before I get it put in. But homework 2 will strictly be on Blackboard, and everybody will get the 10 points because of how I shifted things. Questions? Okay. If there are no questions, then we're going to get into today's information. So we have been talking about measurements. Well, measurements have 2 parts. They have the number and they have a unit. What we have been discussing to this point is the number. The number should be recorded in significant digits. Today, we are going to start with a discussion of the unit. From now on, a unitless number has no meaning. So simply recording a number without the unit on conversions and other calculations will get you 0 credit. So starting today, a number without a unit is a meaningless quantity. So always record the unit with your number. So let's talk about units. The first unit we're going to talk about is mass. Yeah. Now, mass is different than weight. When you go and weigh at the doctor's office or weigh on a scale at home, what you are obtaining is a weight. Weight has a factor associated with it of gravity. Mass differs from weight because when you mass an object, you have eliminated the factor of gravity. Upstairs in our laboratories, we have balances. And these balances have been calibrated so that they eliminate that gravity factor so that you get a mass. So mass is the is a unit of quantity. It's a unit of the amount. I'm trying to not use the term weight, but basically it is a weight that does not have gravity involved. The English unit of mass that many people are familiar with, if you're using a calibrated scale, the English unit of mass might be a pound. But again, that only works if you're using a calibrated scale. Now, we will learn to convert from the English unit into the metric unit. And the metric unit for mass is grams. Represented with a capital or with a lowercase g. There is also the System International. Or SI unit. And the SI unit is actually kilograms. Now, for chemistry purposes, we tend to use the metric system because most of the things that we mass are not in quantities large enough for kilograms. The next unit that we will talk about is length. A unit of length that a lot of people are familiar with is inches or feet. The System International unit is that of the meter, and so is the metric. While we will learn to deal with inches to feet or inches and feet, we'll primarily be converting them into the metric and SI unit. Thankfully, time does not change. It's in we can record it in seconds. Well, we record it in seconds for the metric and for the System International as well. We will use hours, we will use minutes. Time does not change. Temperature, however, does change. In the US, when you watch the news, the weather is reported in degrees Fahrenheit. We will not use degrees Fahrenheit. I mean, we'll learn to basically convert out of degrees Fahrenheit real quick into degrees Celsius, which is what our thermometers upstairs measure, or even Kelvin. Finally, volume. The English system uses cups, gallons and units of that nature. For the metric system, we use the base unit of a liter, whereas the SI unit is meters cubed. Now, we tend to use the metric system or some unit of the metric system because most of the things that we measure are powdery solids, liquids, maybe some gases. But all of these things cannot be measured with a meter stick, which is what would be required in order to use the SI unit of meters cubed. Any questions about the units we use? Now, on the page I handed out, the top half of the page, you will receive on an exam. The top half of the page is broken down based off of the type of measurement you're making. Are you making length measurements? Are you making mass measurements? Are you making volume measurements? The top of the page gives you conversion factors between the English system and the metric system primarily. So again, you will receive the top of this page on an exam to help out with conversions. Now, when you look at these equalities, such as 12 inches is 1 foot, the 1 is always going to be an exact number. So 1 foot is 0.3048 meters. Consider the 1 an exact number, meaning when we start dealing with the calculations, since exact numbers have an infinite number of significant digits, that particular piece of the equality is not going to impact the number of significant digits you record in your answer. Again, consider the 1s to be exact quantities with unlimited number of significant digits. Therefore, the 1 is not going to impact the number of significant digits you record in your answer because they have an infinite number of significant digits. So only the other half of the equality do you have to worry about with respect to significant digits.
Would that make more sense when you actually see it?
Yes. Once we get into problems, you will see, and which will occur on Monday, Wednesday, and Friday of next week, you will see that when we use the 1, which is the exact number, I don't even think about it with respect to the significant digits in my calculation. I only focus on the other. So yes, I think it'll make more sense when we get there. I just am hoping by repeating it, it'll become habit. Okay. Now, the other half of this page, you will not receive on an exam. Meaning you have to have it memorized. The metric prefix conversion factors must be memorized. To help you memorize, if you go into this week's folder, you will find a Quizlet that can help you practice, I should say, in memorizing these. But you will have to have those memorized. You will not receive them. In College Chemistry 1 in General Chemistry for Health Sciences, it doesn't matter. Those are expected to be memorized. So once you learn them, don't forget them, because you will use them again. So I'm going to go over what it all means and how I have developed the table. Now, folks, let me just take a moment and talk about milli, because people may have experience with milli. The way I have milli set up, M-I-L-L-I, which is a lowercase m. The way I have it set up is that 1 milli of whatever. It could be milligram, it could be milliliter, it could be millimeter, it could be whatever. 1 milli is equal to 1 times 10 to the minus 3 of that thing. So 1 milliliter could equal 1 times 10 to the minus 3 liters. The X is just indicating a unit there. Or if I put 1 milligram, it's equal to 1 times 10 to the minus 3 grams. The X just indicates the unit that the two pieces have in common. Now, you may have also seen this as 1,000 milli, let's go with liters, is equal to 1 liter. If you have worked with metric prefix conversions before, and this conversion factor is the one you know, you can use that one. You don't have to memorize these. However, for those of you that have had issues with memorizing your metric prefix conversions in the past, I find this particular method to be the simplest, and that's the reason I gave it to you. So, why do I find it to be the simplest? Because the 1 goes with the prefix unit. Always. Whereas the 10 to the power goes with the unit. Or base unit. The other reason I find it easiest is because when I'm doing this 10 to the power stuff, it's 10 to the 12, 10 to the 9. In other words, I'm dropping by 3, 10 to the 6, 10 to the 3rd. Now, when I get to 10 to the 3rd, I start dropping by 1. But once you get that piece, the other half goes in the opposite, or is just the negative of those. These are always tied to the base unit again. So whatever liter, milliliter, whatever the base unit of that prefix was, that is what that gets tied to. And then it's always, well, I guess it's 1 times 10 to the whatever. And that is equal to your prefix. 1 of your prefix. So 1 tera, 1 giga, 1 mega, 1 kilo, 1 hecta, 1 deca, 1 deci, 1 centi, 1 milli, 1 micro, which is actually the is a Greek letter, 1 nano, and 1 pico. I'm trying to show you because I know students go in on that test and they say, I have to have this memorized. I just showed you the easiest way it is to take what you had to have memorized and quickly write it down on the sheet of paper. Start at 10 to the 12 and drop by 3, 9, 6, 3, then by 1, 2, 1, and then do the opposite. That's always associated with the base unit because the 1 is always associated with the prefix. Now, I did give you a little ditty because I know people like little ditties to memorize, help them memorize the order. And it's from top to bottom. So the great man, King Henry's daughter, drinks cold milk until 9 p.m. forever. I didn't get femto in this list. But I gave you a way to memorize the order too. Questions? Yes. What now?
So what about
femto? I didn't put it on here because it didn't fit on my page. 1 femto is equal to 1 times 10 to the minus 15. Again, it's not 14, 15. Again, though, it's in threes. I just ran out of room on my page. Once again,
If in junior high, high school, you memorize the metric prefix system and you memorized it in a way that works for you and works every time, you're welcome to use what you know. My goal is I've seen too many individuals that do not know the metric prefix conversion factors, and they struggle with the metric prefix conversion factors and memorizing the metric prefix conversion factors. So I gave you a tool. That was my goal, is to just give you a tool. Okay. So let's actually use this tool I just gave you. We're going to use the metric prefix conversion table I just gave you. And we're going to briefly start the topic that we are going to deal with all next week. Conversions. How many kilometers is equal to 0.0269 meters? Okay, when you're dealing with a conversion, you always start with the piece of information you were given. We were given 0.0269 meters. Notice that I included not only the numerical value, but the unit. When you're dealing with conversions, include your units, and it's going to typically just easily wash away. Basically, you'll be able to place the conversion factor the way it needs to be placed. So I have meters and I want kilometers. The conversion factor is this one. 1 kilometer or 1 kilo is 1 times 10 to the 3. In this case, we're talking meters. Why do I know it's meters? Because that is what these two things have in common. According to the prefix thing, 1 prefix unit is equal to 1 times 10 to the 3rd of that unit in this case. You'll know if you set it up correctly if you're paying attention to your units, because your units will cross out. That is because the way I have it drawn, this is division. The parallel line to the floor is division. Whereas the vertical line to the floor is multiplication. Keying this into the calculator. Whoa. It would be 0.0269 divided by, however you want to do it, but 1 times 10 to the 3rd. We've discussed this a little bit. There's 2 different ways you can enter scientific notation. When you key this into the calculator, you get 0.000269, or it may show up as 2.69 times e to the fifth, or e to the negative fifth. Same answer.
So how I fix with my calculator, it always rounds it up for whatever reason. So I won't have 269, I'll have 27.
Okay, so the reason yours is doing that is most likely due to one of your settings. And if you'll stop after class, I will fix the setting for you where it won't round it. But it's most likely due to one of the settings telling it how many decimal places it's allowed. Questions? Okay, kilometer, you could have got, most people can get it a couple of different ways. Let's do a different one. Let's do, oh, by the way, important, before I move on, this has 3 significant digits. The 1 kilometer to 1 times 10 to the minus 3, those are exact, which means they have unlimited number of significant digits. Since the measurement with the fewest had 3 significant digits, your answer is only allowed 3 significant digits. Let's look at another example. Let's go with 2001 micrometers, or let's go with microliters, just to change up the unit, is equal to how many liters? First of all, I know I'm using the metric prefix conversion factors because I'm dealing with liters and liters. That's how you're going to know that it's the metric, is because the base unit will be identical. So I go to the metric and I find that 1 micro of something is equal to 1 times 10 to the minus 6 of that something. You always begin the calculation with what you were given. So 2001 microliters. Your denominator is going to be the thing that has the microliters, because you want your units to cancel. Leaving the other half of the equality to go into the numerator. Okay. It has to do with the fact that you have a 2001 over here, which is this. So number one, you could key it into your calculator, but I will show you the shortcut that I used in my head just now. So this is the same as 2.001 times 10 to the third. And we multiplied it by 1 times 10 to the minus 6. multiplication of scientific notation you add the exponent. So in this case, a +3 minus 6, that's why it's a -3. But the reason it did is because it was 2001 instead of 2.001 to begin with.
So we use converting scientific notation.
I did in my head so that I could make it faster from my math. You don't have to if you're using your calculator. Since we're on this, if you do division of scientific notation, you're going to subtract the exponents. Yes. Repeat.
Instead of using like the conversions every time, if you use the scientific notation, like the conversion factor, then you just use that to know.
Okay. I thought that's what you said, but I wanted to double check before I. So basically, what you are describing is simply taking the decimal place and following what it says. The answer to your question is yes, you can do that if you have been successful with that. I've seen many people that still move it to the wrong place. And so that's why I've got pretty much a set style that I use so that it's always the same at least. But yes, if you've been successful with that, you can do that. You just have to be conscientious of that.
So when we did our table the second time, we had our 1 times 10 to the third power. Why was it when we did the first one, we had just our kilometers, kilometers, and then on the bottom scale of it, we had 10 or 1 times 10 to the third power.
It all depended upon what I needed to get rid of. Because if you'll go back up here, X is, so on that last one, X was liter. On the first one, the X was meter. So don't worry about the X, I'm just trying to point out. So on the first one, I was getting rid of meter, which meant the meter piece had to go in the denominator because those units had to cancel out, which left the kilo piece in the numerator. On that last one, however, I gave you 2001 microliters. So the micro portion had to go in the denominator so that the unit would go away. No, it doesn't matter whether it's negative or positive. What matters is the units have to go away.
So if you start out with micrometers, you got to make sure that this portion is in the denominator in order for the unit to go away. In other words, I'm paying attention to my unit. I'm not paying attention to what the numbers are. So for example, if I take 2001 millisecond and I want it into microseconds, the first thing I note is that they both involve seconds. So that means you're using your prefix table. Now, I find millisecond or milli anything. Which is this one. Because milliseconds was in the numerator, I have to put that 1 millisecond in the denominator. And the 1 times 10 to the minus 3, the other half of that equality goes in the numerator. Because all I care about when I'm putting it in is, number one, I am sticking to this equality up here. I didn't change what was on either side of the equality. All I care about is that I originally started with millo and it has to go away. So they have to be, I had to have it in the denominator. Now for the other one, it's micro. So I look at it and what do I have in the what unit do I still have in the numerator? I have seconds. So which part of this equality has to go into the denominator on the micro? Will this, which is microseconds, go in the denominator, or will this, which is just seconds, go in the denominator? Seconds. So in this case, 1 times 10 to the minus 6 seconds goes in the denominator and the microsecond in the numerator, because again, I want the units to cancel out. Did that answer your question? And then I would do the math. Which comes out to be 2.001 times 10 to the 6 microseconds. Yeah. We're going to do a lot more of these on Monday, Wednesday, and Friday of next week. Yes. Hold on, I can't. Homework number 3 is not going to be due now until the 16th.
Yeah.
Homework 3, right. Homework 3 is all about conversions, and so I'm waiting until we finish conversions for it to be due, so it'll be due the 16th. Exactly. And so, oh, that reminds me. If you were one of the ones we tried to get a jump start on homework, what was 2. And you did not like your grade because I moved it to be homework number 3. You can email me and I'll restart it for you. Because I had about 5 or 6 of you who had started homework number, when it was homework number 2. I had 5 or 6 of you started, and because I changed it, I want to give you a chance to do it after we go over it. So we'll go over it next week, and then you can do it. It's due the 16th. Homework 3. Homework 2 became. Okay. So homework 3 is due the 16th. Everybody gets a free pass on homework 2.
Okay, I think you actually said 2. I was like,
Yeah.
What was homework
3rd.
Yeah. Okay. If you have questions, you can come ask. Otherwise, I'll see you on Monday.
I don't know if this is a long shot, but I wanted to ask anyways. I emailed, I don't remember what day it was last week. I was sick. I woke up with a fever and I missed Wednesday and Friday. And then the next Monday was Labor Day. And then my dad had back surgery on Wednesday. Homework. And I didn't